So the second half of 4.7b is about solving quadratic inequalities. In 4.7a, we graph them. Today, we're going to actually solve them algebraically. Before we do that, I sort of want to review linear inequalities. And I hope that when we did this back in units, I want to say 2 or 3, definitely 2, that the idea was to solve linear inequalities, you just use regular algebra. You just follow one little idea that if you multiply divide by a negative, you got to flip the inequality symbol. But overall, I mean, the same rules of algebra applied. So, for example, if I ask you to solve something like, I'm just totally making this up, so the numbers will probably end up being ugly fractions, but 3x minus 4 is greater than 5x plus 2. The idea is to get all the variables on one side, get all the non-variables on the other. So let's go ahead and subtract 5x just because I like to put the variables on the left. And we'll go ahead and add 4 to both sides. That gives us a negative 2x is greater than 6. This is perfect. This works out evenly. Then divide up the negative 2. Hold up, we're dividing by negative, so this inequality should flip. So we get x is less than negative 3. So that was pretty simple and straightforward. And when it comes to linear inequalities, that's the idea. You don't have to do any fancy tricks. You just straight up and solve it. Well, remember, when it comes to solving quadratic inequalities, we do have fancy methods. Sometimes it takes factoring. Sometimes it takes square roots. Sometimes it takes the quadratic formula. Well, this symbol here, the inequality symbol, they don't really play nicely with those operations. When you take the square roots of both sides with inequality, what happens? We don't know. How do you take a quadratic formula with an inequality? So the idea is that if you have an inequality that's bigger than a linear, you can't solve it directly. It's such an important idea, I'm actually going to write it down. When solving inequalities bigger than linear, we cannot solve it directly. Okay, so if I can't just use straight up algebra to solve, how do we solve quadratic inequalities? Well, the idea is you solve it by graphing. Now, I know graphing is probably everyone's least favorite thing to do in mathematics. Fortunately, we don't have to go all out when it comes to graphing. We can sort of do a shortcut called a sign diagram. But there are a couple of things that we need to sort of have down cold before we move on to this lesson. So let's list down a couple of prerequisites or fundamental ideas. So this is a list of things that we should know and be comfortable doing. If there's anything on this list that you're going, you know what, I still don't know how to do that, hopefully that's a signal for you to go back to the previous lessons and practice on them some more. You cannot learn mathematics by idly sitting by. You have to do some work. So prerequisite ideas. You must know how to solve a quadratic equation. By all methods, you must know how to solve by factoring, by taking square roots, by completing the square, or the quadratic formula. You must know a little bit about the graphs of quadratics. We should know that there are two types of quadratic equations when graphed. You have an upwards parabola and a downwards parabola. And the only thing that determines if you have an upwards parabola or downwards parabola is the leading coefficient. If the leading coefficient is positive, your graph will open up. If the leading coefficient is negative, your graph will go down. We also need to know something about inequalities themselves when it comes to graphing. If your inequality uses an or equals to symbols, we know it will be a closed or a solid line. or let's not use the word line. It will just be closed or solid. If it's strictly less than or strictly greater than, it'll be an open graph, open curve. That's basically it. These are the four. These last two are basically part of the same group. These are the 3 or 4 ideas that we need to have down cold. If you know these ideas, congratulations, you can solve any quadratic inequality you want. For example, you're going to find that once you have these bullet points down, these examples should be easy peasy, a cakewalk. Suppose it asks you to solve, I don't know. Let's start off with something easy here. Let's do x squared minus x minus 6 is greater than or equal to 0. When it comes to solving quadratics, this is what we want. I don't care if it's an equation or an inequality. We want 0 on one side, which we have it here, right? So that's good. Next, in order to solve this, we're going to pretend that it's an equal sign, right? So we're going to pretend it's x squared minus x minus 6 equals 0. This is what you have to solve. So, this is a quadratic equation, so solve it by factoring, solve it by completing the square, solve by quadratic formula, however you can solve it. In this case, it is factorable, x and x, so that's going to be an x minus 3, x plus 2, and then that means it's going to be an x equals 3, x equals negative 2. Once you solved it, you're going to create what is called a sign diagram. So basically, it's sort of like a mini graph, but without the actual graphing. So what you want to do is plot your x-intercepts down. And I don't draw tick marks. I just put them like where I think they are. Oh, negative 2's on the left, 3's on the right. And then I'm going to put little circles on them. Now, these circles will be open or closed depending on the inequality. So I look at the original inequality. Since it has that little line underneath it, since it's or equals to, what that says is it can equal 0. So that means these x-intercept, where the values are 0, are valid points. So I'm going to fill them in. And the last thing I'm going to look at is the shape. So take a look at the original problem. Don't look at the pretend part. Don't look at the blue. Look at the original. See how the leading coefficient is positive 1? See how the a value is positive? That means it will have an upwards shape, right? So if you imagine, you don't have to, but if you imagine, if I were to draw this parabola through these points, it'll look something like this. I hope everyone agrees it'll look something like this, right? So notice how the parts I'm highlighting, see how these parts here are above the x-axis or above the horizontal line? See how this part here that I'm highlighting in pink is below the horizontal line? So I would say that the parts in yellow are the positive regions, and the parts in pink is the negative region. So this has a sign diagram of plus, minus, plus. Well, how does that help me actually solve? Well, let's take a look at the original inequality, shall we? This is the original problem here. What does it say? It says greater than or equal to 0. Now, on a number line, 0, 1, 2, 3, negative 1, negative 2, negative 3, so on and so forth, what type of numbers are bigger than 0? These numbers here, aren't they? And notice, aren't all those numbers positive? And that's exactly what we want. Greater than or equal to 0, that's what the inequality says. It's just a math way of saying, you know what? I want the positive answers. Well, let's take a look at our sign diagram here, right? Let's take a look at this guy here. What color, we only have 2 colors, yellow or pink, what colors are positive? The yellow, right? So look at the region. Don't look at, some of you guys are probably confused, but wait a minute, negative 2 is negative. I'm not talking about the black numbers. I'm talking about the regions, the yellow and pink. And by the previous logic, we said that the yellow, since they're above the x-axis, since they're above the horizontal line, are considered the positive regions. That right there is our answers. I'm going to scribble in black on the number line the part that our answer belongs to. So we said that the yellow part, everything in this region, is our answer. This region, everything in this region is our answer. What we've shaded is our solution. All we have to do is write it down. Now the practice is going to ask for interval notation. What interval notation is basically writing down this graph here but using symbols. We always read from left to right. So notice when we read from left to right, does everyone agree that we start in over here? Well, this shading goes on forever to negative infinity. So from left to right, you can sort of say that we start at negative infinity and shade rightwards until we stop at negative 2. So I'm going to write negative infinity, comma, negative 2. Infinities will always be open parentheses. The actual numbers, they will be open parentheses or square brackets. Which one, how do we tell? How do we know? You look at the shading. If you have closed circles, they would be square brackets. If you have open circles, they will be parentheses. So in this case, I'll have a square bracket at negative 2. I hope everyone agrees that we're not done yet. We still have this region to write down. If your answer has more than one region, you're going to glue your answers together with a union. It's just a capital U without a tail on it. And then you go ahead and describe this region. Remember, we read from left to right. So what number do we start at? We start at 3, and we go rightwards forever to infinity. So that the second part of our answer is going to be 3, comma, infinity. Since 3 is shaded, it'll be a square bracket, and infinities are always open. That should be the solution, all of the x values that will solve the original problem. I'm going to do a lot more examples in this video, so if you're still confused, just keep watching, and hopefully you'll get it by then. Just watch as little or as much as you need until you get this. But solving inequalities, let's summarize. You just solve it like regular, put your answers on the number line, and fill out the positive and negative regions, and read your answer. So let's solve another inequality. Suppose I ask you to solve negative x squared minus x plus 6 is greater than 0. Now, we do have the 0 on one side, so you can leave it like that. But notice how you have a negative in front. You can keep the negative there, or what I like to do is, just because I'm weird, I always like my x squared to be positive. So I'm going to divide out a negative 1. So this gives me a positive x squared, a positive x minus 6, flip the inequality, and I get a 0 here. So now I'm going to think, or I'm going to pretend that it is an equal sign, and I'm going to solve it like normal. So this is very similar to the previous example, x and x. In this case, it will be plus 3 minus 2. So I get x equals negative 3 and x equals 2. Put your answers on a number line, negative 3, positive 2. They're going to stay open because the inequality doesn't have a line underneath it. Also, since we changed it, see how the x squared is positive? He's going to have an upwards shape. Which means, if you sort of imagine it, this part right here is above the line. This part in the middle is below the line. So I have the positive regions on the left and right, and a negative region in the middle. You look at the inequality right before you did the thinking, right before you did the blue. So I'm going to look at this inequality here. See how he's less than 0? Well, what type of numbers are less than 0? Negative numbers. So my answer should be the negative region. If you look at the sign diagram, our negative region is the pink region. So I'm going to shade the pink region. There's our answer. All you have to do is write it in interval notation. Remember interval notation, you always read from left to right. So where does our shading start? Our shading starts at negative 3, excuse me, comma, how far do we shade before we stop? 2. Do you see how both of these circles are open? Open circles will use parentheses. That is our answer. All numbers between negative 3 and positive 2. So that's how you solve quadratic inequalities. The only way I can make this more difficult, and I'm not saying it will be, but the only way I can make this more difficult is, I don't know, if I put numbers and variables on both sides, and if I don't make the leading coefficient 1, right? Say, for example, I asked you to solve, 2x squared minus 14x plus 9 is greater than or equal to x plus 2. So here I put stuff on both sides. Remember, just like solving equations, you want 0 on one side. So I hope it's very obvious to everyone that it might be easier to bring everything to the left. So we're going to subtract x from both sides, subtract 2 from both sides. That gives us 2x squared minus 15x plus 7 is greater than or equal to 0. Once I get 0 on one side and the leading coefficient is positive, I'm going to pretend, or I'm going to think, that it's an equation. And then you go ahead and solve this however you want. Solve it by factoring, solve it by completing the square, solve it by quadratic formula. I know some people like the method. If there's a number from the x squared, you take the first number and you multiply into the last number. So that's x squared minus 15x plus 14. So that should be easier to factor now. So that's x and x minus 14 minus 1. But if you do this weird multiplying method, you have to divide up the numbers by the original a values, which is 2, and reduce as much as possible. So that's x minus 7. Here we can't reduce, so bring the exponent up as 2x minus 1. So that gives us answers of x equals 7, x equals 1/2. Okay. Go ahead and plot them on your number line. 1/2 is over here, 7 is over there. They are going to be, look at your original inequality. Since there's a line underneath it, they're going to be closed. And since the leading coefficient is positive, it's going to open up. This regions here, the left and right, are the positive regions because they're above the line. This region in the middle, the pink region, is below the line, so it'll be negative. The original inequality says greater than or equal to 0, which is positive numbers, so you're going to shade the positive regions. So there is our answer. Reading from left to right, start at negative infinity, comma, and we go all the way to 1/2. Infinities are always open. Since this 1/2 is shaded, it'll be a bracket. We do have another part of our answer, so we need a union. This shading starts at 7, comma, and it goes forever to the right to infinity. That is our answer. I hope that as you do more and more of these, you're going to get the hang of it. You'll find out that these problems are really, really simple. All it is just drawing this sort of graph light with the sign diagram. Look for the regions that you want and solve. Right. Let's end the lesson with just one quick example here. Suppose I ask you to solve x squared minus 1 is greater than 0. Right. So I already have 0 on one side, so I'm going to think x squared minus 1 is greater than 0. Solve it by whatever means necessary, factoring, quadratic form, completing the square. Since I only have a regular x squared term, I can actually solve it straight up. Oh, sorry, I should be thinking equals. I can actually solve it straight up because there's only one x squared term. So let's go ahead and add 1 to both sides and take the square roots. This is what a lot of people messed up on the quiz. Whenever you take a square root to solve, your result will be plus or minus. A lot of people forgot the plus or minus. And of course, the square root of 1 is still just 1. So there are our answers. Let's make a sign diagram, -1 and 1. Our answers will be open because it's strictly greater than. The leading coefficient is positive, so it will be an open circle, or excuse me, it will be an upwards parabola. This region here is positive. This region here is negative. And we are looking for positive numbers. So there are, or positive regions rather, there is our solution. negative infinity to negative 1, union 1 to infinity. So just give it a shot. It just takes practice to get better at mathematics. If you're struggling, if you have any questions, please ask questions. But that is 4.7b.